So in the project view, your configured PLC is here. Okay, if you want to add more slots, you can click here and you can select your module and this will come here. Okay, so let me enlarge it so that I can see my PLC inputs and outputs. So this is quite a decent view at 400%. So you have, these are the inputs, these are the outputs, and that's my LAN interface. So now the next step is we have to link this PLC to my computer. Okay, in that case we have to make sure the IP addresses. So if I check my IP address here, wait a second, just click on this one, double click on this one, and you will have this window and you will see the IP address. This is 192.168.0.1. So this is the IP address already in my PLC. Now the IP address of my Ethernet card in my computer is 192.168.0.2 in my LAN card. So you have to make sure it should be either greater than this one or less than this one. I hope you know this one. This is a basic concepts of networking. So your PLC LAN IP address is this one, and my IP address of my LAN card is 192.168.0.2. Okay, so the next step is the LAN interface setup you can do here. Next step is to write the code. Okay, so to write the code you have to go to PLC program block. So click on this one and you will find the main object OB1. You have to double click this one. So once you double click this one, you will find a programming ladder window. All right, this is the window where you can write the code. So to write the code, what we need: an NO contact, NC contact, output, and NO in parallel. So we'll take an NO contact from here. This is an NO contact, and an NC contact, and an output contact. Now I need an NO contact in parallel to that. So in that case, I'll click this one, and here you will take a parallel output like this. Then you will take another NO contact, and then you have to add this here. To do that, you have to click here once and release the click here. So this is how you can link your output. Now to do the addressing, there are two steps. First step is you can manually write the address. So the address which we need is I0.0, 0.1, Q0.0. So to do that manually, you can double click and write I0.0, press enter. So your address will be entered like this. And this is the tag. This is the comment. You can change this tag name so that you can recognize your input easily. Start. Okay, write start and click change. So if you want to write tag here, another easy way is you can make it to float, and I would like to resize it, and I have my PLC here. So the best way is to quickly drag and drop here my second input. So this is linked with I0.1, and I can rename this tag to stop, and I can see this stop symbol is here and is also in my PLC. I can put my output tag here and I can rename that to light, so it will change here. Another interesting thing is if you just write here light, you will have a tag here. Press enter, enter again, it will show you the same tag. You can also write your tag name as well to get the address automatically. So I will go back to my embed. Now you can see that this is such an easy way to tag your addresses from the PLC itself. Okay, so I will embed that back to my window, and you can see this window here. This is my PLC and this is my main. You can float it and you can embed it back again. So this is how you can write the logic. You can put the addressing. Now the next step is to compile the logic for any error. So the compiling is done from here. This is a compile. Press compile and it is compiling, and if it has any error, it will show you in the window here. This is compile. It shows 0 error and 0 warning. It's compiled successfully. Right, now the next step is to download this logic in my PLC. So to download that, I have to use this button here, download to device. Click here and it will again detect my PLC if it is properly configured, and then it will download to my PLC. So there will be a window which will come, which will show the link of your PC with your PLC. So this is done for the first time only. You have to click on start search. So it will search the IP address which is connected to your LAN card. Okay, so it found one PLC here, so it will show that here. This is my device of PLC S7-1200, and I can load that. So this is done just once because this is the first project we are making. So it says that PLC should be at the stop mode for downloading. The modules are stopped for downloading, so it's okay. I can stop the module. You can click stop all and load. So the PLC will go from run to stop mode. This is the orange light, and then the logic will be downloaded. So it says, do you want to start the device again? I will say yes. So it will move my PLC from stop mode to run mode. So this is at run mode now. Now my logic is downloaded. The logic says if I turn on my first input, output will be latched. So let's check that. This should work. Yeah, this is working. My input is on and output is on. If I turn off my input, my output remains on. It means it is latched. If I turn on my second input, my output goes off because this is unlatched. Okay, so to make it looks more easy to understand, what I can do is I can monitor the ladder logic. This is the next step, monitoring. So to monitor this ladder logic, I can click here, monitoring on and off. So once you click here, it will show you the status of your bits in a real time. So this green means it's true, this blue means it's false. Now this is true, this contact is true. You should not be confused, there is no light here, but this contact is true because this is an NC contact of my second input. So let's first understand the functioning of this contact. This is true because this is false. This is the invert logic of my input. This is false, this is the invert, so this is true. If this is true, this is the invert, this will be false. So let me just make it true. So when I make my second input true, this goes false. Blue indicate false, right? So let's check the logic again. I will turn on my first input. My output is true, so this is indicated by this green lines. This is in parallel, so this is true. And if I turn off my input, this goes false. This is true. Now next, if I turn on my second input, this will be open and which will unlatch the output like this. So this is false, which you can see here, false here. All right, so that's how you can monitor your PLC ladder logic in your software TIA. This is the one way to monitor the logic. The second way is you can do using a watch table. So let's do that as well. I'll go to watch table. I'll click add new watch table. Okay, so here I will put the address I0.0, press enter, I0.2, sorry, 0.1 and Q0.0. All right, these are the three addresses which I'm using in my logic. Then I will go to monitor all. Now you can see that these are false because my inputs and outputs are false. This is also the status of my PLC. This is at run mode. Now if I turn on my first input, you can see that this is true, this is true, so these two are true. I0.0, Q0.0. So this is the another way to monitor the inputs instead of ladder logic. Now if I make it false, you can see the real-time status of my inputs here. If I make it true, the second input, my output will be off, and this is true, so this is true here. So this is the representation of my PLC input and outputs in the using these LEDs, true and false status. And if my PLC is at run mode, you can see that run here. If I make it to stop mode, I can click the stop here. It will give me a warning. Now this will make my PLC in stop mode, and you can see that this is at stop mode. Now when the PLC is at stop mode, your PLC logic will not work. So even if the input is on, as per the logic, it will not solve the logic, so output will not be on. So you have to make sure if you are testing your logic, your PLC should be at the run mode. Okay, so I can go back to run mode. Now another thing we have to understand in this lesson is the force table. Now imagine we are using the same ladder logic and my input is damaged. My input is damaged, this is not working. I'm just giving you assumption, but I want to turn on my output. This is an emergency. Okay, how I can do that? My input is not working. I don't have time to change the input. So what I can do is, if my PLC is already linked to my computer, I can quickly force it. Now to force it, I can go to the force table and I will put the address I0.0, press enter. Okay, this is my force input. Okay, if you remember, this P sign is directly going to my output. Okay, so I'll click on write force to 1. and click yes. So if I force to 1, you can see that my output is on, but input here is not on, but I forced it. Now you must remember that these LEDs are reflecting the status of your input hardware inputs, okay, not the force inputs. If you see the ladder logic, the input I0.0 is true, but here it's written if. It is forcefully true. This is the software interrupt, you can say that. By software, this is true. That's why you have this indication here. Okay, if your input is true by the hardware, you will have this LED here, you will not have this force here. But my objective is solved, my output is on because I forcefully turn it on. I can also forcefully turn it off. Okay, so I'll go back to force table. I will write force to 0. Yes. Now I forcefully turn it off, but my output remains on because this is latched because of the latching. Now next I will forcefully turn this bit on to unlatch my output. This is just for the explanation. So I'll write I0.1, press enter, right click, force to 1. Yes. Now in this case, the output goes off because in my logic, this is true, so output is off. All right. Now you will notice that in PLC we have another light on, which is the maintenance light. Because the forcing is done generally in maintenance mode, so you have this maintenance light on, which indicates that you have some forces present in your PLC. So this is one of the troubleshooting hint. If you are troubleshooting a PLC and you find this light is on, you must understand there is something going on in the PLC. You have some forces on. Okay. So to remove the forces, you can go back to force table. If your objective solved, you can go back, force it to 0. You have to make it to 0. Remove all the forces, then you remove the forces from here. Stop the forces, yes. So when you remove the forces, you can see that this maintenance light is off from here. There is no maintenance light. Now PLC is back to its normal run mode. Okay, now here I can use my input to latch my outputs. Latch and unlatch. So this is how you can use the basic features of the TIA. So what we have learned in this lesson is we have configured the PLC, we have written the ladder logic, we have given the addresses, we have monitored that, and we have forcefully turned it on and off using the force table. So let's go back to our slides to review what we have done. Simple latching circuit, these are the steps which we have followed. So the first step was creating the project. Second was inserting the ladder logic, then addressing the ladder logic. So then it comes configure the CPU, which we done in the first step. Then we added the IP addresses. Then we have downloaded this logic. We have tested the operation in our PLC. Then we have used the watch table for monitoring our inputs and outputs. We have monitored the values in this table, and then we have that's all we have done today. So this is the summary. We have congratulations. Well, you have, if you are following this step in your own PLC along with this video, you have performed the simple basic programming of this PLC. Okay.